Okay. Hi everyone. I'm Nick. Today I'm going to talk about something about account abstraction, sharing some experience about our design and some problem we run into. So the name of my topic is pretty long. It's called Validation-Centric Design, Agile and Safe Development for Devs, and Interchangeable AI Wallet for Users. I'll break down what this means pretty soon. Okay. So here are the parts of my talk, the agenda. First, I will briefly go through what AI is, what AI Wallet is, and how the devs are building that. Next, I will go through the topic, the validation-centric design. And the third part is the challenges that comes with this design. And the last part will be the interchangeable wallets for user, what it means. Okay, so how are AI wallets built today? What is an AI wallet? So it stands for Account Abstraction Wallet, which basically means smart contract wallet. So with a wallet, you can use multi-sig, passkey, email to authorize your transactions. You don't have to use your private key or mnemonic words to do that. You can use whatever methods you want. And next, you can pay gas fee with USDC, USDT, or other tokens, other methods like credit card. You can also do that too. Or you can even get the debt to sponsor your transaction. And the third advantage is that you can recover your wallet if your private key or your method is lost, like your email account is lost. You can still have set out a recovery mechanism in advance to save your wallet, regain the control of your wallet if you ever happen to lose the key, lose the control. And also, you can authorize the third party to perform actions on your behalf, on your wallet's behalf. Like, for example, you want to do a monthly subscription to an app. You don't want to come out and use your wallet to pay for the subscription every month, every week, etc. You can have, with the AI wallet, with the smart contract wallet, you can have third party do that task, do that efforts, running the errands for you. Okay, so in this talk, when I say AI wallet, it also means that it will also be the same as smart contract wallet. When I say a wallet, it basically mean your account, user's account. Okay, how do devs build the AI wallet today? So I'll term the design as account-centric design in the contrast to what I'm talking about today, the validation-centric design. So in account-centric design, account holds the user's asset naturally. That's very obvious. But this account also contains the complex logics like validation logic, like how you validate your transaction, how you authorize your transaction, or how you pay your transaction fees. For example, you can simply hold the ETH on you, or hold the USDC on you, or you can possibly stash your USDC on some DeFi protocol and use it to pay for the fee when you send in your transaction, etc. And you could also have your recovery logic. It could be a very complex recovery mechanism. And you also, the account is also going to be upgradable because as a devs, you know the current version is not going to be your final version. So you have to make it upgradable so you can add in new features, remove, delete old features as time goes. So also, this is optional. The account can be made modular if you're wallet devs. You probably heard of the ERC 6900 or 7579. These are very popular modular standards. So account not only holds the user's asset, but it can also contain very complex logics. And so devs will keep iterating on this same contract. For example, you could start with 0.1.0 and then keep going on to 0.2.5 and then keep going to version 1.0.0. And then one day you might reach to version 2.0 to version 2.0.0. Yeah, so that basically means that you're gonna keep upgrading on this same account. Now, I'm gonna spread some thought about upgradable contracts. So use the last August exploit on the Ronan Bridge contract as an example, which is an upgradable contract. So the Ronan Bridge contract, during its upgrade process, it defines both two functions, version 3 and version 4 initialization function. But only the version 4 initialization function was called during the upgrade. and that leads to the exploit. So if the version 3 initialization was called together with v4, nothing will happen. So it's clearly that it's an operational oversight. The devs forgot to trigger the v3 initialization. So yeah, that's true. But also, you might wonder why would there be version 3 and 4 coexist? Why do they coexist? So imagine you're a wallet devs and your latest wallet version is version 2.00. But your user, Bob, his wallet might still be on version 0.10 or version 0.2.5. But he hasn't used it for a long time. But now, once he came back online, he has to upgrade to latest version, right? So how do you migrate his wallet safely? Are you going to keep upgrading from all this version from 0.10 all the way up to version 2.00? That's going to be a hell of a lot of risks. So now enter the main topic of this talk, the validation-centric design. So quick recap of account-centric design. In an account-centric design, account contains complex logics, validation, payment, recovery, and it's going to be upgradable. And optionally, it could be modular, 6900, 7579. And this is also the same account that users are going to use it to hold the assets and interact with the dApps. So do the above complexities really need to be built into the same account contract? Well, we think not. So we think the better design is to move all the unnecessary complexities out of the account contract. The validation, payment, recovery, upgradability, optional features, move it all out of the account. The account that user used to hold the assets and interact with the dApps. The account contract can be and should be that simple. It just holds the assets and interact with the dApps. So what does it look like? So like here in the picture, user Alice has an account that he holds her assets and use her account to interact with the dApps she wants. And then you have, right now we call it account entry contract. It's a different standalone contract. This account entry contract will give instructions to this account contract. Tell him to do this, like send money to Bob and interact to swap on Uniswap, etc. And this account entry contract can be simple or however complex you want. It can be upgradable, it can be modular, it can have recovery mechanism, you can use session key to authorize third party, you can use a different sort of authorization method to validate your transaction. Yeah. Whatever, it can be simple, it can be complex. So this would be like this will compose a wallet for user, Alice wallet. But ideally, users should not be able to be aware of this account entry contract. And this is what the wallet software needs to do. He needs to hide this complexity to Alice. She doesn't need to be aware of the account entry. She only needs to recognize. She only has to know his account, where she used to hold the assets, use it to interact with the dApps. She doesn't have to know, ideally, she doesn't have to know the account country at all. So you can imagine that Alice can start with a very simple account entry contract with a security level like a brick wall. But later, maybe she wants more features, or she wants her account to be more secure. So what she can do is that she can deploy a new account entry contract with a security level like a stone wall, and you can add so many features and turn it into a Swiss knife. So once Alice wallet deploy and set up the new account entry contract, she can just send a transaction to instruct the account saying that now telling the old account entry contract will tell the account that your ownership is changed. Now you will follow orders from a new account entry contract, and then it's done. You can just simply switch from the new from an old account entry with simple logics, simple features to a very complex one. just one transaction, and you can leave all your technical debt behind. So now, I still have to clarify that validation-centric contract, what it doesn't do is that it does not save the debts from the risks associating with upgradable contract. Whenever you design your account entry contract to be an upgradable contract, you are still carrying the risk with upgradable contract. You might still be running into the same exploit like the Ronan bridge contract. But what it does is that it gives the devs the option to restart, just like the picture here shows. You can simply switch to a different account entry contract. So it gives the devs the option to restart, and in turn, this option allows the devs to iterate at a faster pace. So you can imagine that you might go live, devs, your wallet, you might go live with modular contract 6900, and later, a year later, ERC 7579, a new different modular standard came out, and you was like, oh, this 7579 looks simpler, more abstract, better, but now how do I convert my existing wallet of 6900 to a 7579? Both are very complex, completely different wallet design. Or vice versa, you want to switch from 7579 to 6900. Or you can imagine that you are going from a non-modular account to a modular one because you want more features, or vice versa, you thought the modular is too complex, you don't want that much features built in, you want it to be simple. How do you migrate, how do you change, how do you upgrade your contract from a modular one to a non-modular one? Or you can imagine you go live with this diamond proxy pattern, which is rather new upgradable proxy pattern. Diamond proxy is very modular, very flexible to an extent, but you might begin with this design and later thought that this is the diamond proxy pattern is too complex, too modular for me to handle, too hard to manage. So you want to upgrade back to the upgrade back to the old simple 1967 proxy standard maybe, or vice versa. You want to go from simple to complex. It's all gonna be very difficult if you're upgrading the same contract. So this is what I mean by safe and agile. Options to restart gives the wallet devs safety. You can restart, leaving all your technical debts behind, and the options in turn give the devs to iterate at a faster pace. And this is what I mean by the agile development. You can develop the new standard, new style, new design in the same time parallel. And once you think that's mature, you don't even have to worry about how do you migrate the old account to a new one. You just like switch to a new one without any technical debts. Okay, so there's one additional feature I want to mention that stems from the validation-centric design, which is the multi-accounts. So you can imagine Alice can have multiple accounts, account 1, 2, and 3, and one's account entry contract for her to manage all these accounts. You can imagine that for example, Alice might say that I want to buy ETH using my account 3, and I want to pay the fee using my assets on account 1. So since they all follow the orders from account entry, and she only has this one account entry to send the transactions, so it will be completely natural to control multiple accounts at the same time. So it doesn't you don't have to send 2 transactions to complete the steps. You can complete one multiple account control in just one single transaction. Okay, so there are also some challenges come with the design. The first one is how do we pay the transaction fee? So you might wonder what's the problem. So the problem is that the user Alice send a transaction to this account abstraction transaction. He will send this user the transaction to the entry point contract. And the entry point contract, you can consider it as the operating system contract for the account abstraction system. So you will send a transaction to entry point, but the entry point contract will only recognize account entry contract instead of the account contract. So obviously, the account entry contract now has to pay the fee because that's the only entity that the entry point recognizes. So well, how do we solve this problem? Multiple solutions. Solution one, you can just directly pay from account entry if you have any assets on that. So Alice could, for the convenience, say like just put her assets on the account entry also, and save some, maybe some majority of the assets on the account contract, but leave some on the account entry to pay for the fee. This is one solution, and this will do simply. But you would probably break some user experience, deteriorate that, because ideally we don't want the user to be aware of this account entry contract, right? So solution two, you can transfer from the account, right? After all, you have all your assets on the account contract. So once the entry point asks the account entry contract to pay for the fees, the account entry can in turn ask the account contract to transfer money to him so that he can pay for the fee. But there's a catch that this transfer will violate ERC 7592. This is a bundler regulation rules for AA. All these regulations, all these rules are to prevent bundlers being DOS attacked. So right now, these violate rules, though this is like a soft rules, the bundler really doesn't have to enforce this rule actually. So you can imagine there's bundlers service that provide constant rules, like they are fine with the risk of this transfer, then they can totally accept the transaction and forward the transaction on-chain for you. So this is solution two, is very straightforward, but it also comes with one downside. So right now at imToken, our solution is to use a paymaster to bypass the restriction. So you can have the paymaster that from the fee payment for the account entry for the user, and then charge from the account afterwards, after account finish his operations. So in this case, you don't have to do the transfer from account to account entry, so that won't violate any rules, and you can also complete the flow. Yeah. Okay. Second challenge is not so critical. Is that this flow, this transaction, will not be easy to view on the Explorer. So as I mentioned, the account that user recognize is not the user of sender. That means the sender of this transaction. The sender of the transaction is actually the account entry contract. So when you throw this transaction onto the Explorer, you will see, the user will see that this account entry contract is the sender, but she will probably not recognize this address. So the user cannot easily see which of his accounts are being executed. So, but this is indeed a problem. Less severe one, but still a problem. But it's also the same problem for meta transactions or for contract wallets like Safe, or for some wallet service is experimenting with child accounts, sub-accounts. They all have the same problem that it's not easy to be viewed on the Explorer, because this is all internal operation, internal transaction, internal part of the transaction. So it's not going to be easy for them to view the transaction, to view what exactly is her accounts involved in this transaction. So that's probably a bigger problem to solve for all of us, all of the wallets as a whole. Yeah, so that's the challenges. And the last part is the interchangeable wallets for users. What does that mean? So in the world of EOA, user can just like export his private key from one wallet and just like import his private key to or Nimani word to another wallet and begin using his same account. So it's like same account, different wallets. The only difference are the wallets platform, be Chrome extension, wallet, or wallet apps, different platform and different user experience provided by the wallets. So yes, something like this, same key, same account, different wallets. User Alice can just use it, import, export the key, very smooth. That's the advantage of the EOA. But now with the account abstraction, smart contract wallet emerging, every wallet company is designing their own contracts, their own account contracts. So That means user can no longer use the same account on different wallets. It's all different accounts, different design. And you can just like import, export, import the keys. And user has to create a whole new contract for a new wallet. User has to migrate everything to a new account if she or he wants to use the new wallet, because maybe he finds the new wallet more convenient, more providing more features. So yeah, it's not good. Not the same account, not the same wallet. If Alice wants to like switch to use Coinbase account, she has to migrate all her assets from imToken account to Coinbase account. That's gonna be quite a trouble. So imagine with validation-centric design, wallet companies will focus on developing their account entry contract, all the complexities. And user can just switch between different wallets by simply changing their account entry contract. You can start with imToken. You can point to imToken account entry contract, and later you find Coinbase Coinbase wallet better. You can just simply switch to the Coinbase account entry contract, and maybe one day you find that you still prefer imToken, you can just switch it back. So this is what I mean by interchangeable wallets. For users, you can just remain using the same account, holding the same asset to interact with dApps, and just simply switching between different account entry contracts, so that she doesn't ever have to like migrate his assets or completely giving up his old accounts. And yep, so that's a wrap. This is the resource, our repo, though we are still waiting for our final audit to complete. So before we really open source that, unfortunately, but it will soon be open source. Okay, any questions?
Any questions?
Hi. Yeah. So it means that each smart contract wallet, you will point to account entry, and this account entry will, like, for example, you can migrate to another implementation, for example, Coinbase wallet. But wouldn't that like storage collision be a problem for that?
Yeah, good question. So this is gonna be two independent contracts. So the storage is gonna be completely isolated, independent. This is Coinbase account entry. It has its own storage. Account entry. It's gonna have its own entry. So there's not gonna be a problem of storage collision.
But switching to different account entry, meaning that user will be aware of the change of the address, right?
No. So this is always the address, the account that she recognize. Ideally, she's not going to be aware of this account entry contract.
Oh, okay, got it.
Yeah.
Got it. Okay, thank you.
Hi. Oh. Is there a case where if you try to change your account entry, the one that you're currently on prevents you from redelegating ownership of the underlying account, or is that something that's preventable?
You mean like greedy wallet that doesn't want to let user
raise? They want to lock you in. Yeah.
Unfortunately, it's possible because like there's no rules like how you should design your account entry. So imagine this account is like an account a contract with owner, and she only takes the order from the owners, but she has no rules or powers over how this owner transition the ownership. So yeah, I think that might be possible if a wallet wants to like trap her users in his wallets.
Yeah. So with more competition from all of these wallet companies with each other on the smart wallet accounts, do you think that's something that they would do?
Yeah, I think that's possible, but I think it's still like better than the status quo, right? Because status quo is that none of this is going to happen because the contract, the account is inherently different. So we have no choice. We don't even have the option to migrate without changing the account. That's the status quo. So with validation and centric design, at least we have the option, but though it's true that we can ask the wallets not to do that, not to like trap their users there, but I think it's still better than status quo. Yeah, thank you.
Any last minute questions? We still have 6 minutes. No? If not, then let's give Nick a round of applause and thank you for sharing those